Bismillahirrahmanirrahim. So today we are going to discuss about the isothermal process. If you remember, yesterday we already discussed about isobaric process and isochoric process. The process where the pressure was constant and the process where the volume was constant. Okay. So we saw how to calculate the work done for both the process, and today we are going to see the same for the isothermal process. Now, as you remember, isothermal process. Iso means same. Thermal, it is something related to temperature, right? So isothermal means the process in which temperature remains constant. Okay. So this temperature constant. That means pressure and volume can change, but the temperature has to remain constant. So for this process, how we can calculate the work done? Okay, so in isothermal process, come to page number 12. Okay, at the bottom, we have the isothermal process. Uh, at the right, we have the pressure versus volume diagram, which I will be explaining later. Okay, in the isothermal process, the temperature of the system remains constant so that Boyle's law can be applied. Correct, right? In Boyle's law, we saw that the temperature remains constant, the pressure changes with the change of volume. Correct? And it was inversely proportional. So let a cylinder filled with gas and fitted with a movable piston be our system. The same system that we saw for the last two processes also. We had a cylinder and three side was fixed and one side was, one side was closed with a movable piston. But that piston we consider to be a frictionless one. Okay. Energy can go out and come through through the wall of the cylinder. The energy is supplied to the system very slowly. That means if I want to supply some heat energy, I can supply it from any of the side. Okay, so if you put the cylinder on a Bunsen burner, already you should be familiar with this Bunsen burner thing because you have done you might have seen this in the chemistry lab, right? Okay. So heat can be supplied, and if we want, heat can be taken out also. So if energy is supplied to the system very slowly, then the pressure and volume of the gas will be changed, though its temperature will remain unchanged. That is true. If you think about it in this way, when we supply the heat, what will happen? As a result, the gas will try to expand, correct? Now, if you do not let it expand, then what will happen? The temperature will go up. But if we let it expand as it wants, the temperature will remain same. Okay. So such change is known as isothermal change. The expansion of the gas due to this change is known as isothermal expansion. See, the gas is expanding, and throughout the expansion, the temperature is kept constant, so it is isothermal expansion. Achha. The PV curve of the isothermal process is shown in figure 1.5. Yes, this is the graph that we are talking about. Pressure along y-axis and volume along y-axis, x-axis. And the graph will look like this. As you can see, the volume is increasing, the pressure is going down. The inverse relation, if you remember. Okay. Now, the PV curve, okay, we saw this. This is a rectangular hyperbola. Okay. In isothermal process, the temperature remains constant, so the internal energy of the system does not change. Now, this is the point that you have to remember. For isothermal process, if the temperature is not changing, there will be no change in the internal energy. There will be no change in the internal energy if there is no change in the temperature. So please make a special note of this. This is very important. Okay, these things actually will help you a great deal in the example. Okay, whenever you see that the process is isothermal process, there is no temperature change. So if you do not change the temperature, the internal energy will never change. Okay, now let us take a look at this one. Let us say um, mm, the gas cylinder has a particular number of molecules. Okay, now you are heating it. What is supposed to happen? If you do not let it expand, then what will happen? The collision between them will increase. But if you let it expand, now it has more place. The kinetic energy has increased. Okay, but what will happen if you let it, have more space now? Compared to the earlier case, then what will happen? There will be no increase in internal energy, right? Because the collision will remain the same. The collision will not increase because you are allowing more space now. So as you let it expand, what will happen? They will have more free space. So less number of collisions will be there. Okay. So the first law of thermodynamics that we know, dq is equal to du plus dw. Now we saw that for isothermal process there is no change in internal energy, so this will be 0. As a result, the equation I can rewrite as dq is equal to dw. Okay. Acha. So that is an isothermal process. The work done by the system is equal to the heat energy supplied to the system. Okay. Now, from first of thermodynamics, we saw that the amount of heat energy that we supplied, the part of it was used to be spent for changing internal energy, and some part it was spent for doing some work on the environment. Now, if you are not getting any change for internal energy, that means the total amount of heat energy that you are supplying, you are still supplying the heat, right? So that heat energy will be used in, doing the external work. Okay, no change in internal energy will occur. So in isothermal process, it is P1 V1 equal to P2 V2. Now this is what we got from the Boyle's law also. Where did you keep the duster? For isothermal process, I can write P1 V1 equal to P2 V2. Anybody forgot that we got this from Boyle's law? If you remember, we got from Boyle's law P is proportional to 1 by V. Then P was equal to K into 1 by V. So V, if I multiply here, PV is equal to constant. So if PV is equal to constant, I can write, for P1 V1 equal to P2 V2 equal to P3 V3 is equal to constant. This one will be equal to constant, this one will be equal to constant. So all of them are actually equal to each other. From there, I can write this P1 V1 equal to P2 V2. Achha. Then in case of isothermal change, as we can see, PV equal to nRT. This is also something we know, right? PV is equal to nRT. Okay. Then P is equal to nRT by V. P is equal to nRT by V. This is also okay. So the total amount of work done will be W is equal to, the equation is same, W is equal to P into dV. V1, V1, we start from V1 and we go up to V2. So this is the amount of work done. Okay. Now we will replace the value of P here. Okay. The value of P. Now, if you remember, in case of isobaric process, we got this P out of this integration. Why? Because it was a constant there in isobaric process. Isobaric process means the pressure remains constant throughout the process. So for that process, the pressure was constant. That is why it came out. But now we are studying isothermal process. The temperature is constant. The pressure is not constant anymore. The pressure is also a variable now, which may change with the change of volume. Okay, so as the pressure can change, it is not a constant anymore, and that is why we will not take it out of the integration part now. We will keep inside the integration. Okay, so if I put the value in RT divided by V into dV, correct? Anybody has any doubt?
No, sir.
Okay, great. Achha. Now, if you notice this nRT part, nRT, all of these are constant. Number of molecule, sorry, number of mole, and R is the universal gas constant, and temperature, isothermal process. So the temperature is also constant. So nRT, this whole part is constant, and it will come out of the integration part. So we can write nRT V1 V2 dV by V. Now, if you remember the formula for this one, it is equal to ln V, right? If it was equal to dx by x, then it was ln x. As it is V here, so it will be ln V. Okay, I can continue writing here nRT. If I do the integration, it will be ln V, and the upper limit will be here V2, and the lower limit here, it will be V1. So continuing the rest of the calculation, nRT, it will be ln V2 minus ln V1. That means V will be replaced by the upper limit minus V will be replaced by the lower limit. So if there is minus, if you remember the logarithm formula, what we can write ln V2 by V1. If it is minus, then we can write it as division. Till now, anybody has any confusion?
No, sir.
No, sir.
Okay, so this is equation number 1.24. Okay, so this is the equation to calculate the work done. Okay, we need to know the number of mole, universal gas constant, the temperature, and the volumes, the initial volume and the final volume. Okay, Achha. Since the isothermal process, the change of internal energy du is equal to 0, that we know. Therefore, dw is equal to dq. This one we already discussed about, right? The total amount of heat energy that we supplied will be spent in doing some external work. Okay? No problem. Achha. Oh, yes. Inshallah. Yes. Okay. Achha. So the heat required for isothermal expansion is Q is equal to W. We already got the work done as something, right? Now we know for isothermal process, the work done is equal to the amount of heat supplied, because whatever heat you supplied will be spent in doing some external work only. For increasing the internal energy, there will be no energy spent, right? So the amount of heat energy supplied will be equal to the amount of work done, and for that we have already developed an equation, that is nRT ln V2 by V1. Okay, so we can use it as work done equation or heat supply equation also for isothermal process. Okay, and this equal to the area of ADBA of the indicator diagram. Now we are talking about the area under the curve. I already told you, whenever we have the P versus V diagram, PV diagram, okay, whatever the graph is, okay, let us say I started from here. This is the V1 and this is V2. So what is happening? That we are getting our area under the curve, right? So if I can find the area under the curve, then I should be getting the work done. Okay, so here whatever the work done I will get, that should be equal to the area under this curve. Okay, this is what they are saying. So from the area of the indicator diagram, we can directly determine the amount of work done by a heat engine, right? That is, work done by a heat engine is W is equal to, we know this already, right? this is the equation 1. If you take a look at 1.25 equation, that is the equation that we started with when we were deriving this equation. Okay, so do I need to explain the 1.25 equation anymore?
স্যার একটু লিখে দেন ইকুয়েশনটা স্যার।
ও এটা প্রুফ করার সময় আমরা যে ইকুয়েশনটা দিয়ে শুরু করছি এটা সেটাই, v1 থেকে v2 p dv।
বুঝছি স্যার, লাগবে না স্যার।
Okay, so the next process that we have is adiabatic process. Adiabatic process. Now in this process, what remains constant? The heat energy. Okay, no heat energy is supplied to the system. Q is equal to 0. Now what is Q? Q is the amount of heat supplied. You will not supply any heat to the system. That is adiabatic process. Okay. Now I already gave you a little bit of idea about this. That if we know that dQ is equal to du plus dW. So if I'm not supplying any heat, so dQ will be 0, then du plus dW will be there. Okay. Then if I change the side now, what will happen? dW will be equal to minus du. If you change any one of it, okay, one of them will become minus. Okay. Okay, so adiabatic process. Let us go through the definition once again. The thermodynamic process in which no heat can go out of the system. Just give me a Acha. The thermodynamic process in which no heat can go out of the system nor can enter. So no heat exchange. So in short, you can write the process in which no heat exchange occurs is called adiabatic process. Okay. So if we can thermally insulate the system, insulator, if you remember, we talked about two types of insulator. Okay, one insulator through which the current cannot pass, the electron cannot pass, the resistance is high enough to block the current. So that is one insulator for current. Another insulator is that insulator through which the heat cannot pass, like felt. Okay, tula. That is why the blankets are made of insulator. Now what is the purpose of this insulator? See, whenever during the winter season we use this blanket, okay, because in winter season our body loses heat because the surrounding temperature is below. Okay, it is quite below our body temperature. So as a result, what happens? Our body starts losing temperature and it starts to get cold. We feel cold. Okay, now whenever we are wearing the blanket, what does this blanket do? This blanket does not let the heat escape. Okay, it traps the heat inside the blanket. As a result, we feel a little bit warm. Okay, because the heat is not leaving the space inside the blanket. Okay, so inside the blanket a warm environment is created. So this is what is insulator. Okay, so we need to insulate a system if I want a adiabatic process. Okay, insulate the system so that no heat can enter, neither any heat can go out. Okay, acha. So if we can thermally insulate the system from the environment, or we can expand or compress the gas very quickly, then we get an adiabatic process. Now without insulating, if the process takes place very quickly, then also we can consider that for this quick change, the heat did not get any chance to go out, nor heat got any chance to come inside. Do you understand my point? Okay, if the process takes place very quickly, then the heat will not get enough time to go out or come in. Okay, so in that case also we can consider the process to be an adiabatic one. Okay, So the change of the system during this process is called adiabatic change. Yes, because we are considering no heat exchange is occurring. The expansion of gas during this process is known as adiabatic expansion. Change during this process is adiabatic change. The expansion during this process is adiabatic expansion. The compression of the gas is adiabatic compression. Since no heat can enter the system nor leave the system, so dq is equal to 0, which I already showed you. Okay, therefore from the first law of thermodynamics we can write 0 is equal to du plus dw. Then from here we can write two of the things, du is equal to minus du, dw is equal to minus du, or du equal to minus dw. Okay, now during adiabatic expansion the work done of the system is performed by the internal energy of the system, so the internal energy of the system is decreased and the system is cooled. Okay, this is what I tried to explain in the earlier class when I was giving you a little idea about the adiabatic process. Okay, now the way I like to think about is, let us say dq is the amount of money supplied. Let us see if you understand this analogy or not. du is the amount of increase or change in your savings. Increase in your savings. And dw is the amount of money spent. Okay, so now let us take a look at this and let's see if we can understand this or not. For isothermal process, what did I tell you? Before isothermal process, let us talk about the first law of thermodynamics. So according to the first law of thermodynamics, if I supply you some money, some part of the money you will use to increase your savings. That means you will keep that as your savings. The rest of the money you will be spending. Okay, so this is validated, right? Then when we are talking about the isothermal process, we say that we are not saving anything, no increase in your saving. What does that mean? The money that I have supplied, if you didn't save it at all, that means you have spent it all. Do you understand my point? Okay, if I have supplied you some money, you didn't save it at all, then what will happen? All of it you have spent already. Now let us think about the isochoric process. In isochoric process, no work is done. If you remember, isochoric process means the volume was kept constant. As the volume was constant, no work was done. That means you didn't spend any money. Then what will happen? The money that I will supply you, it went to your savings full because you didn't spend a single penny. Okay, so we can just replace the money with heat. Okay, now let us think about this adiabatic process. Okay, interesting. Money supply. হ্যাঁ বলো
স্যার বাংলাতে করেন স্যার।
বাংলাতে আমি কি ইংলিশ এতই খারাপ বলতেছি?
না স্যার, একটু মানে কনফিউজ হয়ে যাচ্ছে স্যার, বারবার
কনফিউজ হয়ে যাচ্ছ? আমি আবার শুরু থেকে বলবো, কোনো অসুবিধা না আছে, এবার বাংলাতেই বলি, দেখো বুঝো কিনা। ঠিক আছে, ফার্স্ট ল অফ থার্মোডাইনামিক্স থেকে আমি শুরু করছিলাম। ফার্স্ট ল অফ থার্মোডাইনামিক্স কি বলে? তোমাকে যদি আমি কিছু পরিমাণ টাকা দেই, সেই টাকার একটা পার্ট তুমি সেভ করবা, আর সেভ করা বাদে যে পার্টটা থাকে সেই টাকাটা তুমি খরচ করে ফেলছো, ঠিক না? যদি খরচ না করতে সেটাও তোমার সেভিংস এর মধ্যেই থাকতো, কারেক্ট কিনা?
জি স্যার।
ওকে, এবার আসো আমরা যে প্রসেসগুলো অলরেডি দেখছি সেই প্রসেসগুলোর জন্য এবার আমরা একটু দেখি যে এই ইকুয়েশনটা কিরকম হবে। আমরা দেখছিলাম আইসোকরিক প্রসেসের জন্য the volume was constant and as a result the work done was zero. work done মানে কি? মানি স্পেন্ট, মানে তুমি যতটুকু টাকা খরচ করতেছো সেটা জিরো, তার মানে তুমি কোনো টাকা খরচ করো নাই। এখন আমি তোমাকে যত টাকা দিলাম তার থেকে এক টাকাও যদি তুমি খরচ না করো, তার মানে পুরো টাকাটাই তুমি সেভ করে ফেলছো না? পুরো টাকাটাই, মানে এই যে ডিকিউ পুরোটাই এখন ডিইউ হবে, মানে হচ্ছে যতটুকু মানি তোমাকে সাপ্লাই দেওয়া হচ্ছে টোটালটাই তোমার সেভিংস ইনক্রিজ করার কাজে লেগে যাবে, কারণ তুমি কোনো মানি খরচ করো নাই। This is for isothermal process. Okay, then let us talk about the isothermal process. Isothermal process এ কি ছিল? তোমার du 0 ছিল, এইটা 0 ছিল। isothermal process এ এটা 0, তার মানে হচ্ছে আমি তোমাকে যে টাকাটা দিয়েছি থেকে 1 টাকাও সেভ করো নাই। তার মানে কি? পুরো টাকাটাই তুমি খরচ করে ফেলছো। the money supplied was equal to the money spent. যত টাকাই দিছি তত টাকাই তুমি খরচ করে ফেলছো, so as a result তোমার সেভিংস এ কোনো ইনক্রিজ হয়নি। কি বলছে বুঝতে পারছো জামান? না বুঝলে আবার বলো, অসুবিধা নাই। This is the case of isothermal process. Now we are talking about the adiabatic process. এইটা বুঝতে সবচেয়ে বেশি এই জিনিসটা মাথায় রাখা লাগবে, সেটা হচ্ছে আমি যদি তোমাকে কোনো মানি সাপ্লাই না দেই, তারপরও তুমি যদি কিছু মানি খরচ করতে চাও, তাহলে ডেফিনেটলি সেটা তোমার সেভিংস থেকে নিয়ে খরচ করতে হবে। এবং তুমি থেকে নিয়ে খরচ করো, তুমি কিছু মানি খরচ করছো, সো DW it will be positive because you have spent some money. আর এইটা খরচ করতে গিয়ে তুমি তোমার সেভিংসটাকে ডিক্রিজ করতে হয়েছে, তাই না? এই কারণে সেভিংসটা কি হবে, এখন মাইনাস হবে, মানে ডিক্রিজ হয়ে যাবে। এটাই আমরা মূলত এখান থেকে বুঝতে পারি। আমি তোমাকে কোনো টাকা দেই নাই, তারপরও তুমি কিছু টাকা খরচ করছো, তার মানে তুমি তোমার সেভিংস কমাই ফেলছো। Do you understand this analogy? এখন
yes sir,
replace the money thing with heat. আমি তোমাকে কোনো হিট দেই নাই, তারপরও তুমি কিছু কাজ করে ফেলছো, তার মানে তোমার মতো অলরেডি যে এনার্জি ছিল সেই এনার্জি থেকে তুমি কিছু খরচ করে তুমি কিছু কাজ করে ফেলছো। So there is a decrease in your internal energy because আমি কোনো হিট সাপ্লাই দিই নাই, আমি কোনো এনার্জি তোমাকে দেই নাই, তারপরও তুমি কিছু কাজ করছো, তার মানে তোমার মধ্যে যে এনার্জি ছিল সেখান থেকে কিছু খরচ করে তুমি এই কাজটা করে ফেলছো। তো এই মানিকে যদি আমরা এখন হিট দিয়ে রিপ্লেস করি, তাইলে আসলে আমাদের ঘটনাটা এখন বুঝে ফেলবো। সেভিংস হচ্ছে ইন্টারনাল এনার্জি, ওকে, আর এনার্জি মানি স্পেন্ডটা হচ্ছে এনার্জি স্পেন্ড। এনার্জি কখন আমরা স্পেন্ড করি? whenever we are doing some work, so this is work done or energy spent, both of them are same thing. Okay, so here I will write heat supplied, okay, increase in internal energy, and here it is work done, or you can say energy spent, because whenever we are doing some energy we are spending some energy, whenever we are doing some work we are spending some energy. Okay, so now this adiabatic process is clear that whenever we are not supplying any heat but still we are doing some work, so there will be a decrease in internal energy, a decrease in your savings. This internal energy is like your savings, you have it already saved in you, but if you get a new energy and use that to do some work, then it's okay, no problem. But if you are not getting any kind of energy but still you are doing some work, that means you are using the energy that you already had. Okay, so there will be a decrease in your internal energy, and that is what we represent by here. Okay, তুমি যতটুকু কাজ করবা ঠিক ততটুকু ডিক্রিজ হবে তোমার ইন্টারনাল এনার্জি। ওকে, সো মাইনাসটা কেন আসতেছে? মাইনাসটা অ্যাকচুয়ালি ডিক্রিজ বোঝায়। কিভাবে ডিক্রিজ বোঝায়? দেখো DW এটা পজিটিভ, DW is positive. Why? Because you are doing some work, right? Okay, now why DU is negative? Because তোমার এটা ডিক্রিজ হচ্ছে, তাই না? ডিক্রিজ যদি হয়, the final internal energy minus the initial internal energy will give you a negative value. Why it is that? Because we say that the internal energy is decreasing. That means U1, the initial internal energy, it was higher, now it has decreased, so U2 will be lower. So lower minus higher value will definitely give you a negative value, right? So that is why this minus represents the decrease, okay, with the increase of this work done. Anybody have any doubt till now?
no sir.
স্যার আপনি কি বলছেন এটা আবার বলবেন?
কোনটা ইরফান?
যে U2 U1 এটা কি বলছেন আপনি একটু আবার বলবেন?
DU, D দ্বারা আমরা চেঞ্জ বুঝাই, তাই না? and U মানে ইন্টারনাল এনার্জি, so DU মানে চেঞ্জ ইন ইন্টারনাল এনার্জি। সো চেঞ্জটা আমরা কিভাবে ক্যালকুলেট করি? ফাইনাল মাইনাস ইনিশিয়াল। ইনিশিয়াল ছিল U1, ফাইনাল হচ্ছে U2। এটা তো বুঝছো, তাই না?
হ্যাঁ স্যার এটা বুঝছি।
আচ্ছা ঠিক আছে, এখন দেখো যখন আমি তোমাকে বলতেছি যে তোমার ইন্টারনাল এনার্জি ডিক্রিজ হবে, আচ্ছা ইন্টারনাল এনার্জি কেন ডিক্রিজ হবে সেটা তো বুঝতে পারছো না? বিকজ তোমাকে আমি কোনো কিছু সাপ্লাই দিয়ে না, স্টিল তুমি কিছু কাজ করছো, তার মানে তুমি তোমার ইন্টারনাল এনার্জি খরচ করছো। তো তুমি যদি তোমার ইন্টারনাল এনার্জি খরচ করো তাইলে কি হবে বলো তো? তোমার ইন্টারনাল এনার্জি কমে যাবে না? সো ইন্টারনাল এনার্জি ডিক্রিজ হচ্ছে। তো ডিক্রিজ হওয়া মানে কি ইনিশিয়ালি যেটা ছিল ডিক্রিজ হয়ে তোমার U2 হইছে, তার মানে U2 টা কি একটা ডিক্রিজড ভ্যালু, মানে কম, লোয়ার, আর U1 হচ্ছে হাইয়ার। তো তুমি যদি লোয়ার কোনো কিছু থেকে একটা ছোট ভ্যালু থেকে একটা বড় ভ্যালু মাইনাস করো, তাইলে কিন্তু তুমি একটা নেগেটিভ ভ্যালু পাও, তাই না?
আচ্ছা এখন বুঝছি স্যার।
Okay, good. So let us continue. So this is the equation number 1.26 that I wanted to discuss with you. Okay, page number 14, equation number 1.26. Now during this adiabatic expansion, the work done by the system is performed by the internal energy of the system. বুঝতে পারছো? যে টাকাই ও খরচ করে পুরো টাকাটা ওর যে সেভিংস ছিল ওখান থেকে আসতে হয়, বিকজ ও বাইরে থেকে কোনো টাকা পাই নাই। ওকে, so this is there, performed by the internal energy system, so the internal energy of the system is decreased. দেখছো, internal energy
Sir.
কমে যাবে। এখন হ্যাঁ বলো।
I think time শেষ।
টাইম শেষ? ও 9:51 হয়ে গেছে। আচ্ছা ওকে, নো প্রবলেম। আমরা আসলে এইভাবে আগেলে, আচ্ছা ওকে, অসুবিধা নেই, আরেকটু ফাস্ট যাইতে হবে আর কি, ইনশাআল্লাহ। see you in the next one ইনশাআল্লাহ। আচ্ছা আজকেই তো আরেকটা ক্লাস আছে তাই না?
হ্যাঁ স্যার।
আচ্ছা ওকে, so see you then. আসসালামু আলাইকুম ওয়া রাহমাতুল্লাহি ওয়া বারাকাতুহু।